Hello everyone, welcome to the study of second order linear ordinary difference equation with the constant coefficient. Here you are going to solve the second derivative of y with respect to x minus 6, first derivative of y with respect to x plus 9y is equal to 0. So to solve this, we are going to let our y be equal to exponential mx. Then from here, we get y prime. You differentiate y, which will give you m exponential mx. Then you also differentiate y prime again to get m squared exponential mx. You can call this 2, and this other equation here, we call it 1. So equation 2 consists of y is equal to exponential mx, y prime is equal to m exponential mx, and y double prime, which is equal to m squared exponential m2. So the next thing we substitute. So substitute 2 in 1. We substitute 2 in equation 1 to obtain the following. So instead of second derivative, we are going to obtain m squared exponential mx minus 6m exponential mx plus 9 exponential mx, which is equal to 0. Then we factor exponential mx, which is common, to be left with m squared minus 6m plus 9. This will give you 0. Now, exponential mx can never be equal to 0, meaning that whatever is remaining in the bracket, it is the one which is equal to 0. So this implies that our m squared minus 6m plus 9 is equal to 0. This is a quadratic equation. So whereby we have the product of this quadratic equation is 9, and the sum, product 9, sum negative 6. So two numbers which when you multiply you will get 9, it is 3 and 3, and when you want you get negative 6, it is negative 3 and negative 3. So you factorize this. When you factorize this one, this quadratic equation here, we shall obtain m minus 3, which is equal to 0, meaning that our m1, which is equal to m2, is equal to 3. So our solution will be of this form. Y is equal to c1 exponential mx plus c2 x exponential mx, which is equal to c1 exponential 3x plus c2 exponent x exponential 3x. That is our solution. So we can check our solution. So we get y prime you will get 3 c1 exponential 3x plus c2 exponential 3x plus 3 c2x exponential 3x. After differentiating that once, so we differentiate this twice, second derivative, so this will give you 9 c1 exponential 3x plus 3c2 exponential 3x plus 3c2 exponential 3x, then plus 9 c2 x exponential 3x. That is what we obtained. We can check whether they are like term. We have 9c1, so that is not like, but we can group these two because you have 3c2 and that, so you will have 9c1 exponential 3x plus 6c2 exponential 3x plus 9c2x exponential 3x. So our quadratic is y double prime minus 6y single prime plus 9y is equal to 0. So we want to substitute that value and see whether we will get 0. So we shall have 9. We are going to have 9 c1 exponential 3x plus 6c2 exponential 3x. I'm right substituting this one plus 9c2x exponential 3x. Then we substitute the value of y single prime and then we multiply it with the negative 6. So you will have 3 times negative 6, which will give you negative 18 c1 exponential 3x. Then you have 6 times c2, which will give you minus, because there is a negative here, 6c2 exponential 3x. Then you have the next one, negative 6 times this one here, negative 6 times 3c2xr. So it will give you negative 18 c2x exponential 3x. Then you have 9y you are going to have plus 9c1 exponential 3x plus 9c2x exponential 3x. This is equal to 1. So we have 9c1. We group the one with 9c1, so we have this minus 18, which will give you negative 18. Here we have another 9, which will give you 0. So the values with the c have given us 0 plus, then we have 6c2. Then you have this negative here. That one gives you 0. That gives you 0. So the other part with the c2 has given us 0. Then you have 9 c2x minus 18 c2x, which give you negative 9. Then you come to this other one here, which is 9c2. So negative and the negative will give you 0. So 0 plus 0 is equal to 0. So our working is correct. And when you are given OD, this one, y double prime minus 6, y single prime plus 9y, the result is equal to 0. Our solution we have obtained is y is equal to c1 exponential 3x plus c2x exponential 3x. That is our auxiliary solution. So thanks so much for taking your time to study with me on online difference equation, that is linear of second order with constant coefficient. For more examples, kindly tune to my YouTube channel so that we may continue learning together. Remember also to subscribe to the channel so that you not miss a single video which I upload for us every day.